Okay, so I'm putting on the recording, okay? So
Okay.
you see for basic 41A, right?
Mm-hmm.
For here, we already have the f of x equals to x squared, right? G of x equals to 3x minus 2, right?
Mm-hmm.
So you were just talking about number 1, right?
Yeah.
Number 1, you just go by the definition. The definition tell you just add the two functions. So that's going to be x squared. That's f plus g. That's it.
Oh, so you literally just leave it like that.
That's right. The next one, f plus g of 2. Right? What it means is f of 2 plus g of 2. And that equals to f of 2, right? So for f of 2, you're going to replace
So I'm gonna put a 2 squared.
2. G of 2, 2 times 2, 3 times 2. So this is going to give you 4. So you're going to put 2 squared there. And you're going to put G of 2 there. And that you're going to calculate. Does that make sense? So you're going to have a
Yeah.
numerical answer. That's what you do. Do you have any other questions? Go for it, because I'm putting the recording. I'm going to make everybody to watch this. I'm going to let other people to watch it because I'm sure you're not alone.
So the final answer would just be 8, correct?
That's right, for number 2.
For
For number 3, for example, let's do number 3, shall we?
Yeah.
Number 3, suppose we do subtraction, right? So this is number 1. This is number 2. And this is number 3. Right?
So that would be
subtracting.
f
right?
of x minus.
So
g.
f of x minus g of x. That's my g of x. Right?
Yeah.
And you're going to open up the parentheses. Right?
Yeah.
X
So
squared minus 3x plus 2.
3x.
That's number 3, done. Oh, number 3, number 4, repeat it. My bad. Okay, so let's look at number 5.
Oh, so when you do the subtraction, you have to factor it out to each one of them?
You just distribute the negative sign to each term in the parentheses, right?
Yeah.
Right? That's what you do.
Okay. And then can we do one of the ones at the bottom?
The composition, right? Do you talk about the same basic 41A?
Yeah, just like one of the composition ones.
Which one?
I'll just start with number 11.
Okay. Number 11. Number 11. Number 11 says F composite G. F composite G, parentheses, of X. Right? So what you do, go by definition, we know that this is 2 machines, right? F of G of X. And this process Okay, so let me explain to you at the same time. So we're gonna have parallel explanation, okay? If you are in the future, you're gonna be doing programming, right? You're writing, programs. What happens is that you have X serve as the input for G. Okay, the G function. And the G function will produce an output for you, G of X. And G of X will serve as input for F, right?
Mm-hmm.
And this is going to produce an output, which is of F of G of X. This is the composition. Mathematically, we write it this way. F, right? So where are the functions, right? So we have the functions. So I'm going to put the function next to us. So this is for the convenience of explanation, right?
Mm-hmm.
So F and G are there. So let's go back here. So make it nice and clean, right? So this is usually this is actually called flowchart. If you go to, in the future, you learn how to do programming, this is called flowchart. But now mathematically, we don't do this, right? Mm-hmm. So you do G first. So you do the G first. What is G? G is 3x minus 2. So we finish the G. Okay? G of X, you just replace it by 3x minus 2 because 3x minus 2 is the same as G of X. That's the rule, right? That's the rule for G. Mm-hmm. Next, for F, we have F of 3x minus 2. So F of X is x squared. These x's are placeholders. So when that place is replaced by 3x minus 2, all the placeholder with the same name will be replaced by the same quantity. So over here, you're getting what?
So am I gonna put x squared?
You're gonna have 3x minus 2 squared. You can FOIL it, whatever you do. Okay. If you want, you can expand it. Okay. That's the result of FOIL. You want me to get into the details of FOIL this?
I'm good.
You're good. Okay. And so that's number 11. You get it?
So the whole thing gets squared, not just 3x squared. Because
no, it's the whole thing, the whole input is squared, because this rule says, give me the input. I'm going to square the input. That's what it says.
Mm-hmm. So
that's the rule. No matter what the input could be an elephant. You're going to square the whole elephant.
So let's just say f of x was 5, right? I would do 5, and then I would FOIL the 5 to the 3x. And
right. Whatever that input, that's a whole.
Okay, so it goes to the entire thing.
Right. If your input is an apple, you square the entire apple, including the kernels and everything.
Okay.
Make sense?
Yeah. And then can we just do one of the ones with like 3?
Of course.
Like number 16, because I'm not really sure how to do that.
Sure. You want to do 17 instead?
Is that one harder?
Which one you want to do? I can do any one.
I'll just do 16. And then I think 16. I'll be good for today. Yeah.
Sure. 16. 16, we only need a G, right? Because the G composite itself 3 times.
Mm-hmm.
Okay. Here, the domain range is not an issue because the domain range is always the same. In this case, domain range is the same. Okay. The input is X and it go by G. The rule of G, it produces the output is G of X. Domain range are the same, so we don't have any problem, okay? Domain range wise. But when it comes to G composite G of X, okay, this parentheses over here, it's actually optional, equals to, right? So what you do is it's actually G of G of X. That's what it is. The flow chart, meaning you give the input and this G of X gets it first. The inside most of G get it first. Do you follow me?
Wait, inside G gets.
And you get a G, you already get a G of X. The inside first.
Okay.
Okay. And this produces the output. And this output will give to the next layer. Okay. So this guy is given to G again. It's still the same rule, but the input is different. It's G of X. So coming out, you're going to get G of X. And this guy is going to serve as input for the outermost layer G. You follow me? So one more time. And it produces the final G. So that's the flow chart. Okay, if you write program, this is how you usually do it. But mathematically, we don't need to see this. But in your mind, you do. You should see that. Okay, because computer programming is done this way. Everything's from mathematics. All right, so next, let's see how we do it. From inside layer, we do it from the inside first. Okay, the inside is 3x minus 2 replaces G of X. You see that? So we have finished this piece, but we have 2 more pieces to go. But this G of X, which is 3x minus 2, is the input for G. Okay, this is our G. This is our G. This rule of G says, you give me the input, okay? I'm going to take the entire input. Okay, I'm going to take the entire input. So this piece, right? So if you give me X, I'm going to produce you 3x minus 2. If you give me an apple, and this is going to be an apple. So the X is merely a placeholder. So when we encounter this piece is 3x minus 2, that heart becomes 3 minus 2. Do you see that? You see that?
Wait.
Okay. When the input is a heart, it's 3 times the heart, right? When the input is 3x minus 2, is 3 times 3x minus 2. This whole thing, see it as in a box. You see that? This box is the heart.
Okay, wait, so.
Do you get it?
Kind of, wait, minus 2. So then I do.
I'm sorry?
One second, I'm just writing it down.
Yeah, but do you follow? Take your time. Take your time. So whatever this is, it could be very complicated input. But no matter what's the input, you take the input, you multiply by 3 and subtract 2.
Okay.
So now the input is 3x minus 2. you treat 3x minus 2 as this one single box. And then you replace that box by its equal. Do you see that?
Yeah.
And
So
of course, you will simplify this a little bit, right? So that's g of 3x minus 2. You will open up the parentheses and you simplify, right? You get 9x minus 8. So by the time you're here, okay, so let me draw a little arrow here. Okay, so hopefully that helped. In the
then I
first time, I'm sorry?
So would it be 9 and then parentheses 3x minus 2, close the parentheses, minus 8?
Right.
Next one.
Just hold on. Let me just, because I'm thinking of explaining this to everybody, right? So
Yeah.
when your input is x, right? So this, we're not done yet. We just finished this piece, okay? So the first piece, we get 3x minus 2, right? So this guy was 3x minus 2 from g of x. So this guy was 3x minus 2. So the 3x minus 2 now is the input to g. So by the time it comes out, by the time this is the output, right? So that's going to be over here. Okay. And this time it's 9x minus 8. Is that what you're trying to say?
Yeah, so then
So the
you
second
put-
time, so you're going through the machine 3 times. Each time you use the output from last time. Okay, this is the second time. And this output, which is this guy, is going to go through the same machine. It's going to produce something else. It's going to produce something else. Okay, we are to find out. So g of, so over here, the second time you do this, g of 3x minus 2, g of 3x minus 2, that's 9x minus 8. Do you follow me?
Yeah.
Now you're dealing with, now inside the box, you still use the same machine. So inside the box this time, we're dealing with g of 9x minus 8. So 9x minus 8 is going to be in the box. In the box. You follow me?
Yeah.
So that is equals to 3 times that box minus 2. So you're repetitively using the same rule, but each time the input is different. Because you use the output, the previous input output as new input.
Mm-hmm.
And in the end, what do we get? G of 9x minus 8. If you simplify this, you get 27x minus 26.
And then that's the final answer.
That's the final answer.
Okay. And do I just write 27? Okay, like that. Oh.
Does that make sense?
Yeah.
Okay. This piece is the mathematical expression. This piece probably is a computer science expression, which is a flow chart.
Mm-hmm.
Okay, you can see the power, the composition, right?
Yeah.
The power of composition.
I think I'm good for today. I'm just gonna try and do the rest of them, and then if I have questions, I'll come again tomorrow.
That sounds amazing. Thank you. But you can come back anytime.
Yeah. I'll see you in like 45 minutes.
Yes. Great job, Hazel.
Thank you.
Great job.